In this slidecast, we'll look at an application of the list class. Our problem is that we want to maintain a list in alphabetical order, even after students have been added and dropped from the course. Now, if we do an analysis of this problem, we could develop a general ordered list class that we can use to store any group of objects that can be compared using the less than operator. So we could either extend the C++ list class to recreate a new class, ordered class. Okay, so we could use, that means we'd use inheritance. Or we could create an ordered list class that uses a list to store the items. So this would be using this has a property, that we'd have an ordered list class. It would not inherit from any other class, but we would use the existing list class in C++, as the private data member to actually implement it. Now, with those two options, if we implement this ordered list class as an extension of list, then that client would inherit all of the functions of the list class that could insert new elements or modify existing elements, and they might be able to use that in such a way that we no longer have an ordered list. So we're going to choose to use the second option, which is to have the list as a component of ordered list. And that way our public methods can carefully use just the methods needed, so we can maintain our ordered list and not let clients have the power to sort of circumvent our goal here. Here's a UML diagram. We'll have our ordered list as a template class. We'll provide these four methods to insert and remove items and to create an iterator that points to the beginning and the end. And then this is how we represent the has a relationship, that the ordered list has a list as a data member, and its type is the standard library's template class list. So we don't provide an iterator class because it could be used to change the values in the list in such a way that the order is not preserved. And because list's erase function takes an iterator parameter and not a const iterator, and there's no efficient way to convert from a const iterator to an iterator, we will not implement the erase function for the ordered lists, even though erasing an element does not violate the ordering of other elements. So here's our data field. That'll be a list. Here are the functions we'll have in our class, and here's their behavior. To define the const iterator type, we'll use the typedef command in C++, and typedef lets us create an alias for a type. So for this typedef, we will alias this type name, meaning the standard library's const iterator, and we'll set that equal to const iterator. So in our program, we can use this new type name const iterator, and it'll be equivalent to the standard library's list class const iterator. Now the insert function, if we have the following four nodes and our iterator is pointing to the third node with Karen, then our algorithm for insert is to find the first item in the list that's greater than or equal to the item being inserted, and then we insert the new item before this one. And we can refine the algorithm so that we can create an iterator that starts at the beginning, and while the iterator is not at the end, and the item at the iterator position is less than the item to be inserted, we'll advance the iterator. And then once we find the first item that's greater than the insert item, then we'll add it before the current iterator position. Here's code for insertion. We'll take an item. We'll create our iterator that points to the beginning, and while we're not at the end and the current data item in the list is less than the item we want to insert, we'll advance the iterator. And now that the iterator points to the first item that's greater than or equal to the item, or it points to the end of the list, then we'll go ahead and do our insert. So if all the current elements in the list are less than the item, we'll add the item to the end of the list. And we'll just simply, the insert method on our ordered list class is going to make use of the insert method that's defined in the C++ list class. And this is an example of delegation. So delegation means that the remaining functions are implemented via delegation, and they merely call the corresponding function. Okay, so this calls a similar function, but it's not delegation because we do some extra processing. But notice here, for the remove method on our ordered list class, we simply call a list remove, and when we have the begin method simply calls the a list begin. So this is an example of delegation. We can simply use an already defined method on the current data type that we're using to implement our data type. And here's some code from your book. Here's the ordered list header file, and here's a test program to test this ordered list. And this type's really small here, so I'll let you go into your book and study this code and see that you understand every statement that's here. And that's the end of this slidecast.